Example, Euler Diagrams number 1. Consider the deductive argument. All cats are mammals, and a tiger is a cat. So a tiger is a mammal. Is this argument valid? So the premises that are made are all cats are mammals, and a tiger is a cat. And the conclusion is a tiger is a mammal. So if we look at the diagram that's drawn to the right, this represents this argument. We have a large circle labeled mammals. Within that, we have a smaller circle labeled cats. And within that, we have a little X labeled tiger. That represents the fact that all cats are mammals, that circle being completely contained inside the larger circle of mammals, and a tiger being a cat represented by the element that's inside of cats. And the answer is yes, that is a valid argument. So let's consider some other arguments. Analyzing arguments with Euler diagrams. To analyze an argument with an Euler diagram, draw an Euler diagram based on the premises of the argument. The argument is invalid if there's a way to draw the diagram that makes the conclusion false. The argument is valid if the diagram cannot be drawn to make the conclusion false. If the premises are insufficient to determine the location of an element or a set mentioned in the conclusion, the argument is invalid. Example, Euler Diagrams number 2. Determine the validity of this argument. Premise, all cats are scared of vacuum cleaners. Premise, Max is a cat. Conclusion, Max is scared of vacuum cleaners. So let's see if we can draw these premises. All cats are scared of vacuum cleaners. So we have scared. And if that is true, then we have a circle for that. Inside this, we have cats. All cats are scared of vacuum cleaners. Max is a cat, meaning he's necessarily inside the larger or the smaller circle. So therefore, Max is scared of vacuum cleaners. The only place that Max can be placed is inside of the circle that's labeled cats, which is inside the circle labeled scared. So we have to think about the location of where he would be. And in this case, yes, we can conclude that Max is scared of vacuum cleaners. Example, Euler Diagrams number 3. Determine the validity of this argument. Premise, all firefighters know CPR. Premise, Jill knows CPR. Conclusion, Jill is a firefighter. Let's use the space to the right to draw an Euler diagram. So it appears we have the group people who know CPR, people who are firefighters. And then Jill is going to be placed on this diagram somewhere. So the first premise, all firefighters know CPR, actually makes CPR the outer circle and firefighters the inner circle. So firefighters are a small circle inside the circle of CPR. Jill knows CPR. So there are two places we can actually place Jill. Either inside CPR but outside firefighters, or inside CPR and inside firefighters. Because we cannot know for sure which location, whether she's in the firefighter group or not, the conclusion that Jill's a firefighter is not valid. And by the way, we're doing this with Euler diagrams determining these arguments, but you actually can use truth tables to determine if an argument is valid or not. And we're not doing that in this course, but that is a valid way to determine validity of arguments. Example, Euler Diagrams number 4. Determine the validity of this argument. Premise, all bicycles have 2 wheels. Premise, this Harley-Davidson has 2 wheels. Conclusion, this Harley-Davidson is a bicycle. Use the space to the right to draw an Euler diagram. Now the way the first premise is stated, all bicycles have 2 wheels, actually places bicycles inside of the circle 2 wheels. a circle labeled 2 wheels. So we have a larger circle with 2 wheels, bicycles placed inside that. Harley-Davidson has 2 wheels, so once again, it can either be placed inside 2 wheels but outside bicycles, or it can be inside bicycles. Since we cannot with certainty determine which location this is, we cannot conclude that this Harley-Davidson is a bicycle. This is not valid. Example, Euler diagram number 5. Determine the validity of this argument. Premise, no cows are purple. Premise, Fido is not a cow. Conclusion, Fido is purple. So where is Fido? Is Fido purple? And let's use an Euler diagram to determine that. No cows are purple. Alright, so we're going to actually have 2 circles labeled cows and purple. Because cows are not purple, according to this, those 2 circles do not overlap. Well, if Fido is not a cow, not in that one circle, does Fido have to be in the circle labeled purple? No, Fido could be outside of both of those circles. So where is Fido? Outside both circles. Both sets. Is Fido purple? No.